In selective repeat, packets are individually tracked and acknowledged. A buffer at the receiver side is used to track the received packets until a bunch are available in order so that they could be delivered to the upper layer. Sender also maintains a buffer and tracks timer for each of the unacked packets and only retransmits the packets that are unacked and timed out. The size of the window imposes limitations on the unacked packets that we will discuss. Note that in selective repeat, sender and receiver windows might be at different sequence numbers based on the packets and acts on the fly. The windows slide forward when there is no gap between the act packets on the observed side. So, the selective repeat sender receives data from above. If the next available sequence number is within the window, it sends it and it starts the timer for the packet. When timeout happens for packet N, only packet N is retransmitted, and timer for that packet only is reset. The window is moved forward when the packet N received fills a gap at the beginning of the window close to send base. At the receiver side, if a packet received is within the window range, an ACK for that packet only is sent. If the packet is within the window range but out of order, meaning there are other packets expected between this packet sequence number and the base of the receiver window, the packet will be buffered. If the packet is in order, it will be delivered to the upper layer, advancing the receiver window base. If the packet is outside the window range, if it is previously ACKed, it will be re-ACKed. Otherwise, it will be completely ignored. Assume we have a window of size 4. This means the sender could have 4 unacked packets on the fly. It sends packets 0 to 3 and waits for acknowledgements. If a packet, for example packet number 2, is lost, but packets after 3, 4, and 5 received, they are acknowledged individually but not delivered to the upper layer. When packet 2's clock times out, only packet 2 is resent. At that time, packet 3, 4, and 5, which were buffered at the receiver side, could be delivered to the upper layer. But what happens when the ACK 2 arrives at the sender? What happens when an ACK arrives in the sender side depends on the correct selection of the window size. Let's explore that with an example. Let's assume we have sequence numbers 0, 1, 2, and 3, and window size is 3. In scenario A, we will consider first sending packets 0, 1, and 2. The receiver receives them and acknowledges all of them. And since they met the expected sequence number for sending the data up and updating the sliding window limits, the window at the receiver will be updated to waiting for packet 3, and the next 0 and 1. Now, what if ACKs of the received and acknowledged packets are lost on the way? The window on the sender side is not updated, but the window on the receiver side is updated, and the retransmit of packet 0 sent from the sender could be mistaken as the new packet 0 on the receiver side that is waiting for it. This is wrong. So the question is, what relationship between sequence number range and window size should be maintained to avoid the problem we just saw? The size of the window should be less than or equal to the half of the size of the sequence number space. I will leave the discussion of why for you.